Hi, I'm Kelsea Brennan-Wessels, and in this special edition of Earth from Space, we join you from the Living Planet Symposium in Prague. And I'm joined today by Peter Land from the Plymouth Marine Laboratory, and he's also a scientist on the Ocean Flux and Pathfinder's OA projects. Now, of course, in these projects, we're looking at carbon, atmospheric carbon, that is absorbed by the oceans. Why is this important to study?
Well, the oceanic sink of carbon is really important in mitigating the effect of anthropogenic carbon dioxide on the atmosphere. So it's very important to understand the mechanism of this sink and whether it's how it's going to change in the future. So that's what the Ocean Flux project is about. But also, all this CO2 going into the ocean is having the effect of decreasing the pH of the ocean, and that's called ocean acidification, and that's what the Pathfinder's OA project is studying.
And what sort of effect does this have on the marine life?
Well, it's early days for ocean acidification, so it's very difficult to directly measure effects on marine life at the moment. But people have done lab experiments with the sort of acidification that's predicted for the future, and they've found that some animals find it difficult to grow and grow their shells, so things like corals.
So how do you use satellite data in your work?
Well, satellites provide a large amount of data covering the whole globe and at regular intervals, and so it's got a large amount of data, but it doesn't measure exactly what we want to measure. Whereas people in ships and other in situ measurements do measure things like pH, which is exactly what we want to measure, but it's very expensive, and remote places are difficult to get to, and so these measurements are very sparse spatially and temporally. And so what we're aiming to do in the Pathfinders project is to relate the two measurements so that we can take the sparse in situ measurements and spread them out over the scale of the satellite measurements.
Are there any specific areas where you've seen particularly interesting results?
Well, the Amazon plume is a very interesting area. It's a band of fresher water which extends from the mouth of the Amazon in South America all the way across the Atlantic to Africa. And it's highly dynamic and has very strong salinity gradients, which makes it ideal for satellites to study. And indeed, we've found that of all the methods we've looked at, satellites are the best. Satellites like SMOS, which measures salinity, are the best way to relate the sparse in situ measurements to the big picture over the whole Amazon plume.
Well, Peter, thank you so much for your time. And to our viewers, remember that to learn more about space or about our planet, you can visit our website at www.esa.int.